Good afternoon, everybody. My name's Howard Long, and I guess was involved quite heavily with the creation of the Funcube dongle. I don't know, has anybody not heard of the Funcube dongle? Oh, no. Right, okay. This is a little picture. If you look at the top here, this is the original design of the Funcube dongle, which is done on a little notebook, and essentially there's not really been a great deal of change from that design to what actually came out in the end. I think this picture was taken about maybe 6 months or so ago, when that was probably the entire inventory of Funcube dongles in the world. And that's a 5p coin on the left-hand side, which is about the same size as a US dime, to give you an idea of the size. So it's not a lot bigger than a sort of memory stick. It's about the same size as a TV USB dongle. So the basic idea of the Funcube dongle is to be a receiver, to receive the Funcube satellite. That was the design criteria. It was meant for educational outreach, so it wasn't originally designed for people to hack. That's probably a key point to mention, because there has been some sort of negativity from some people who say, oh, I bought it so that I could take it apart and rewrite the firmware, etc., etc. Well, what I'm going to do is I've got one here which is taken out of the case, and I'm going to pass it around, and I want you to make your mind up if you would like to hack this. The parts on here are quite small. One of the unique selling points was, I thought, if you can have more than one unique selling point, was the form factor. And I never realised this was going to be so popular, because the form factor, I think, is one of the key things that makes this so popular, is that you can just carry it around with you and you've got a radio receiver. So I'm just going to pass this round. This is serial number 2209. So it's probably the last one that's come off the press. Okay, I need to sort of battle along with this. So I've just gone through what we were trying to achieve at the beginning. We wanted something that was not intimidating, so people know about USB dongles. And it's for everybody, amateur and non-amateur. And a really simple turnkey solution. So basically, you plug it in and away you go. And low cost. All of those things truly are very difficult to do. And if you add into the additional thing that I mentioned, hackability, that makes it very difficult to. It's really a complete contradiction. So this is what we had in mind. You might have seen this before. When I did my presentation last year, this is what we had in mind back in March of last year, and so the idea was that we'd have this satellite, or more than one satellite, whatever, but it was really just for Funcube. The little dongle, we'd have a PC, it plugs into the USB port, onto the internet, into a telemetry data warehouse, and you'd have many of these around the world, all squirting data from the satellite into the telemetry warehouse. And this was a form factor that we had. A USB dongle, but with the antenna integrated into it. Now, you'll notice that we haven't got the antenna integrated into it, and there's a good reason for that. Mostly that the amount of RF that comes off your average computer is quite high. So as soon as you put your antenna right close to the computer, you're going to get your noise floor rise about 20-30 dB, just all the hash coming out of there. There's an alternative that you could do was to put an antenna connector on it, but I was worried about that. How much is that going to cost? I mean, if you go in DigiKey or RS, or you go to Mouser, you'll look up, oh, I want an SMA connector or an RF connector, and they're going to cost you $3, $4 a pop. Now, we're trying to keep the cost down, so I was actually really trying not to do that. However, I've since discovered that if you want to order several hundred of them, and you find some fella in China who's willing to sell them for you. So I went to this guy, I said, can I get some SMA connectors? He says, oh, how many do you want? I said, 500. How much is that going to be? And I was sort of waiting for sort of, 1,500 quid or something crazy. And he says, it's going to cost you $250. Okay, so that's 50 cents a pop or whatever it is. Then I said to him, okay, well, how much do I want to buy 2,000 SMA connectors? And he said $350. So my SMA connectors are now only 19 cents or something crazy. So it then becomes actually quite a cost benefit to be able to use a connector, and it means we can take the antenna away from the computer and be able to receive stuff. And if anybody wants any SMA Edge connectors, I've got plenty of them. This is the result. This is actually as at July 2010, this time last year. This was what I demonstrated last year at the Colloquium. This was the state of it. The only fundamental difference I think between then and now is that we're no longer using a PIC 32. I may actually get it into a PIC 24. Again, it's all part of trying to reduce the cost. PIC 32's got a price point of about, I don't know, £5 or so, and the PIC 24 goes down to about £3. So it's all down to reducing the cost of the bill of materials. This was us the month after the Colloquium, and I've taken it from that horrible bird's nest here and managed to get it into the dongle format that you can see being passed around now. And there's a schematic here. This was the original schematic that we did. There's a PCB layout. There's not many changes to the schematic since that, but essentially that's the design there. Then the month after that, in September, we started to think about, well, hang on, how are we going to productionize this? And with that, we need to think about certification. I got very lucky. I gave us an earlier presentation at the Motion Microwave Roundtable, and I was put in touch with a gentleman there, and we managed to get the CE certification through off the back of that, which was really helpful. And also, I was thinking, well, how am I going to make these? Because I was thinking, well, we're going to make 100 of these, right? Tops. So I thought, well, let's see how we get on with actually soldering them. So I think I've soldered together maybe half a dozen of them manually. But how do you solder these chips here? These are QFNs. They have no leads on them at all. And the answer is you use something called reflow, which you use a solder paste rather than solder itself. You put the parts onto the paste on the board, and then you stick them into your reflow oven, which you can get for about £10 at Argos. So this is just a toaster oven, or pizza toaster oven, I think, whatever they call them. And I've got a whole load of electronics here, which are built up to control the timing. It's got a thermocouple in there. It's making sure that the reflow parameters are all perfect, and they ramp up the temperature correctly, and it ramps it down the right time. It's great. The only thing is I do it manually, and all I do after all this electronics is I just push the button, look through the window. When the solder starts melting, okay, it's time to switch it off again. That's it. It's done in 3 minutes. Total overkill. I have not had any failures of components just by looking at it, seeing the solder melt. Okay, we're up to temperature. Let it go. And there's one of the early examples of when I was doing putting the solder paste on. So what you do is you get a board, and there's a stencil up here, and then you put some solder paste on there. You get a squeegee, push down on it, and you can see. Hopefully, you can see in here. You can see that the pads are slightly raised with the solder paste on there. And then you get your tweezers out, and these are the parts here, and you go around and put them on. And doing one at a time, it probably takes about, I would say, 3 hours. But if you're doing 10 at once, you can do 10 in about 6 hours. And it's all to do with the fact that you have all the parts, all the sort of 10 nanofarad capacitors all out in one go. There's a video on the internet, if you look it up, has got a background of Doctor Who going on. And you can see me sort of doing there and doing a set of 10 boards, and it's quite soul destroying actually, sitting there with a microscope doing that. But if you like seeing paint dry, I did that for several days over last Christmas. When we were originally testing it, we discovered that actually, although the manufacturer's specification had a relatively low noise figure, which is about 4 dB, we found down in VHF it was much worse than that, more like about 14. So we needed to put an LNA in there. This is a rework in a very early one. Hacked on an LNA in there. And here are some receiver tests of 2 meters and 70, 2 meters actually. Okay, basically we're down to 0.122 microvolts on 2 meters for 12 dB SINAD. Without the LNA, it's 0.334 microvolts. So we get a much better result when we put the LNA in there. And that's how it stuck. And we looked at a few different LNAs. This is one. This is a Philips one. Again, if you buy them one off, they're probably about £1 or 2 each. But if you buy them 500, they're about 20p. So again, it's this cost reduction. This is in October. I started a website blog, which you may have seen, which is www.funcubedongle.com. Did some user testing, had some of my colleagues on the Funcube technical team on the satellite side were helping me with that. We did all sorts of things such as the gain distribution testing within the unit. Also testing it on, see if we can get it to work on Macs, on Linux, on various versions of Windows. One of the great things that, another one of my unique selling points on this whole thing was one of the problems that you have with USB devices is that they're always asking for drivers and no one's ever got the right drivers. So it was specifically designed such that you should not need any drivers. They're already included in the operating system. So when you plug it in, it doesn't ask for, oh, where's my drivers? So it almost completely gets rid of that problem. The place where it doesn't is a few OEM versions of the operating systems and Windows don't have HID, one of the drivers that's required. It's not very many, probably about 1 or 2% of distributions don't have one of the drivers we've discovered. Also, we need to develop the bootloader. So the idea of it is that what I was afraid of was that we distribute the dongle and then we discover, oh, we need to do a firmware upgrade. And there was some talk, oh, well, what can go wrong? And famous last words, the last thing you want is a recall. I've probably spent about 3 weeks getting the bootloader right. I haven't had one instance. What I was really worried about was what happens if you brick the device, i.e. you accidentally upload something to the device and it just gets stuck in a loop and you can't fix it and have to send it back. That's going to be very expensive for us and very difficult to resolve. So the bootloader went through quite a bit of testing and I haven't had one brick device yet. So there's all sorts of stuff in there to ensure it doesn't brick, to make sure that the firmware that's being uploaded to is kosher. We also developed a little application to work with the dongle, which is down here. You might not be able to see it at the back there. Because there's already lots of software out there which works for SDR, what we wanted, the other thing, as well as the drivers, we wanted it to be compatible with that software, so we didn't have to rewrite that. So there's software like Rocky and SpectraView. There's a whole raft of programs out there that you can use on things like on soft rocks. So we thought, well, why not just rather than reinvent the wheel, let's use that. But we have an additional complication here, and that's that we have a frequency agile device here. So whereas a soft rock, a vanilla soft rock, is on a fixed frequency, with our Funcube dongle, as well as the 2 meter segment we're interested in for the Funcube satellite, we've actually discovered that we can span a huge range of between around 52 megahertz and about 2.2 gigahertz. So we've got to control what frequency it's actually going to be zeroed on. And with that, we have to have a frequency control application. So vanilla, without using any other sort of software, you can just take normal SDR software that works for a soft rock, and you take this little application that we have here, and you're able to control the center frequency of it, and just any software that you've used for your soft rock. more recently, we've found that, to my delight, other people have taken the API that's provided for the dongle, the application program interface, and they developed their own software. They've enhanced their software, so you no longer have to have this additional program running. You can just use a piece of software integrated into the software, a piece of SDR software with a frequency control integrated into it. Plus, also, there's all these crazy parameters down here that we've given you. One of the key benefits here of the device itself is that we're using a set-top box tuner. That was pretty much the thing which made this device work and be low cost. So we're using a set-top box tuner chip, which costs about £2.50, and that's in volume. And that includes mixer, VCO, PLL, various amplifier stages, quadrature, bits and pieces, and a whole bunch of things that you can control down here. So I've given access to all of the various gain settings in there. So because people like to fiddle, I've given people access. When you actually initially sort of set it all up, there's a defaults button which you can do to sort of zero everything back to sort of normal. But that was something that we decided to provide there. Maybe I should just go through what's the thing that you'll see on when you see the device come around. It's got 3 big black chips on it. Well, not big, but they're 3 biggest black chips. One of them is a silicon tuner. That's nearest to the antenna connector. The one in the middle is just a codec, which is an A to D converter to take the tuner's analog baseband and convert it to digital. And then the other chip, the nearest USB, is a PIC 24. Okay, so that was October. Oh, November. Oh, I'm running out of time already. I thought, well, let's cover bases here. Let's get 2 people to do the assembly for me, because I'd already built about a dozen of these by this time, and I was bored already. So I thought, well, let's get somebody to do this externally. So I got 2 assemblers, a guy in Wales, and also set up an assembler in China. And the idea was that we'll just see how we go. The first boards were due in early December from the chap in Wales. You basically pretty much need to give 4 to 6 weeks advance notice for assemblers, certainly on the first go. So you say to them, okay, here's my board layout, here's a placement of components, here are the parts, or you give them a bill of materials and they'll procure them. And I've never done manufacturing before, but it was a hard uphill struggle. We announced 2 models, a base model, which is for educational outreach, which will be frequency limited, and a pro model, which is the ones that are being sold at the moment. The only difference is that they're not frequency restricted on the pro models. The actual device itself is largely identical from a hardware base. It's just what we inject into there for the firmware. And we also announced that it was going to be available in December, and the price is going to be £99 plus the VAT. And also the Pro model is also funding a significant proportion of the Funcube satellite. And also in November we actually managed to use a dongle to receive telemetry frames from essentially a prototype satellite. So we proved that the dongle could actually receive telemetry frames. Then in December, here's a chap you might know, Richard Garriott. Bumped into him wearing his Blue Peter badge in London, and I said, "Oh, Richard, can I get a photograph with you holding a dongle?" And so sure enough, he obliged, nice fellow that he is, and so we managed to get a picture of him holding a dongle. And then my life changed. And what happened was, I mentioned to you need about 4 to 6 weeks to get these guys up to speed on the assembly side. What that means is that they don't start work until 4 to 6 weeks. They don't actually do anything until 4 to 6 weeks. They go right up to the line. So my first assembler he got all the parts to make 100 boards, and he says to me the day after he was meant to deliver, despite me phoning him up the week earlier, everything's okay, yes. He says, can't make these. I said, what do you mean you can't make them? Can't make them. Machine won't do it. So he sent me all the parts back, and I thought, oh, well, it's not too worried. I've got some people in China looking at it. But I thought, this isn't good. So I thought, well, I did guarantee that I would get some out for December. So before Christmas, I spent about a couple of weeks starting to make them up myself. So I sat down there at the kitchen counter, microscope, tweezers, Doctor Who, and started building them. So there's about 100 parts on each board. So by the time you've done, I receive the boards in a panel of 10, and I do 10 at a time. And so in total, you've got 1,000 parts to place. And so I sat down there, and I did every day. I got up in the morning, and I placed the parts on 10 boards, put them into the highly expensive reflow oven, took them out, visual inspection, test them, and pretty much that was my life for about 2 weeks. Now, I also promised to get some out before Christmas. I just managed to squeeze in 35 units just before Christmas, so I had kept my promise of let's have some units out for before Christmas, and they sold out in a minute. And I will never forget this. I was sitting there with PayPal, and you're pressing F5 on the refresh, right? So I'd announced the sale and everything, and the girlfriend's sort of sitting there, or she was in the kitchen making some omelette. Well, she was trying to make an omelette, but unfortunately the microscopes and the reflow ovens were getting in the way. And I'm sitting there, I said, I'm just going to see what happens, and I'm pressing F5, 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 and 40 seconds later, there's like £4,000 sitting in the account. I'm like, what's going on here? So, interestingly enough, another gentleman that's part of this project, who I don't think any of you will know, maybe Graham might know him, is G4ULI. He's my father. He's also a bank manager, and he does my accounts. And he was very negative about this. He said, I don't know what you're wasting your time for doing this. You could tell, look, he didn't have to say it, you could see the look on his face. Anyway, so I phoned him up and I said, no, let's go, guess what just happened? He says, what? He says, yeah, those, my first batch of units, they sold out in a minute. He says, what? I said, oh, okay, fair enough. I said, can you set me up on your PayPal account? So I said, well, my PayPal account. Anyway, so then in January, got the second batch of 65 units. They sold out in about a minute. And it wasn't me phoning my dad this time. It was him phoning me up, saying, you just got £7,000 sitting in your PayPal account. And I'm going, yeah, like this. And he changed in seconds. I was no longer this loser guy just on this, crazy project, what's he doing? It completely changed his mind. Anyway, the bad news was that the units came in from China. So these up until this moment had all been units that I'd built myself, hand-built. Some units came from the Chinese manufacturer, failure rate of 40%. Disaster. What was worse was that the detail it was that they'd used parts off the back of a lorry for one of the voltage regulators. There were a number of other things as well. But they'd persuaded me to procure the parts rather than me give them the parts, and they'd use these ripped off or failed parts, and I spent the next week debugging every single board. And the failure mode was such that it was actually going to break the tuner chip as well. So reworking a tuner chip is quite a lot of hard work. There's QFN, you've got to lift it off. It's about 20 minutes work to change and whatnot. So it took me about a week to deal with that. And also at this stage, although I just got these 100 units from the Chinese, I was still building units myself because I couldn't trust what was coming through from the manufacturers. Third batch of 100 sells out in about a minute. So, by this time I was thinking, this is just crazy, this is. And then I found out from this Chinese manufacturer, they can't deliver for another 6 weeks. The next batch said, what do you mean you can't deliver 6 weeks? Oh, we've got Chinese New Year. I'm thinking, no. We shut down for 2 weeks. So I thought, okay. Then out of the blue, a manufacturer who I'd asked for a quote for about sort of 10 weeks earlier says, oh, do you still want a quote for this? And I said, yes, but how quickly can you do them? Oh, we can do them next week. I said, what? You can do them next week? So this manufacturer, I said, where are you? He says, Letchworth.
You better explain that to the interview.
Yeah, sorry, Letchworth is about an hour's drive from where I live. So I thought, yes. So I trundle up to Letchworth, shake hands with the guy, have a trip around his manufacturing facility. Now, if you may remember, I was going like this with tweezers, maybe placing 3 parts in a minute if I'm lucky. This guy's got these machines, right? And they're like this. And it's soul destroying. So I'm thinking, I quite like the idea of this. Now, he was more expensive than the Chinese, but it wasn't, it was still doable. So I got him to do it. Sure enough, he delivered. So I started buying parts by the 500 rather than the 100 at this stage. We're pretty much from there. We've continued to use him. We've had trouble trying to get the production up to the number of units we really want. I think we're just about there. He's managing to produce about 200 units a week now. That's pushing me because I can just about push out 250 units a week myself because there's the logistics of packing them. Also, every single unit I test myself. I get about a 97% test positive rate from the assembler. And then about the remaining ones that don't test right are generally down to the RFN. They're not sensitive enough. They haven't got enough image rejection. And almost all of these now, it's straight down to the tuner chip. I have to lift the tuner chip off and replace it. We've sold 2,101 since December. My return rate at the moment is 0.5%. And of those, about half of them, I can't find out what the problem is. So I'm assuming it's operator error or something. But when I send a replacement back, there doesn't seem to be a problem with that one. So I'm not quite sure yet what that is. But because it's so low, the return rate at the moment, I think if you've got a return rate of 0.5%, I think that's pretty good. Yeah, we had a real massive week at the beginning of July. I did over 250 units. We managed to push out the door in July, but that's quite hard work doing that. We switched from Royal Mail to FedEx for overseas deliveries. Back in February, March, I was spending half my waking hours chasing dongles around the planet. Although with Royal Mail you get a tracking number.
And he works in the United Kingdom.
Yeah, it's. I don't know how to, but also it doesn't matter what you do. You'll spend hours on the telephone, and the answer will end up being it either got delivered or it didn't. Now, whether it got delivered or didn't is irrelevant because the buyer, as far as PayPal is concerned, if they say they didn't receive it, even though Royal Mail says they did, it's still not enough. So I switched to FedEx. Now here's a deal for you. I said to FedEx, he said to me, how many are you going to do? So I said, I don't know, maybe a couple of hundred a month, something like that. And I said, okay, we'll come up with a deal for you. So here we go. I can send out up till about 5 o'clock on the day, and next morning it will be in the US, and it cost me, I think, about £14 to do that. I mean, the service is absolutely incredible. You can get something, and most of Western Europe as well, same thing. They will arrive the next day. Compared to Royal Mail, which was, well, it's not a guaranteed service. It might take 6 days, it might take 8 days. You can only put in a claim after 6 weeks, and then you have to wait for 3 months for a response. I have one guy in India. We're still trying to resolve it from February. So, but the amount of time it takes chasing these things up is just outrageous. Oh, we also discovered what PayPal's maximum transaction rate is when doing this. We did a graph when we had a sale of about 150 units once, and we had a look to see what happens. And you can see on this graph it just goes, and then it tops out at about 3 a second, and it can't take any more. And then you can see it. Then you'll just see it drop, and that's when we've run out of inventory. Sorry? I say USB stick. I didn't do, the ones that you got, I don't believe I did that. I think I called them a USB radio, and then I found I had to fill out 500 more forms. So I just call it a USB stick now. Okay. Yeah, I just call it USB stick, because that's what it is. Yeah. If you say it's radio, you're just asking for trouble to fill a load of forms out, so I don't. Okay, this is a close-up of a unit, as I think it's still going around, unless someone's pocketed it. This is the tuner chip. This is the latest version. This here is the codec, and this is your PIC, and this is USB connector, of course. In the newer versions, you'll see I've switched the crystal. There's only one crystal on the board. Everything is derived from that single crystal. Apart from on here, the PIC actually has its own internal reference for USB. What else can I tell you about this? There's some Esd protection there on the antenna connection, ESD connection here on the USB connector. This here allows you to shove 5 volts up the connector for an external preamp.
Double-sided or multi-layer?
It's double-sided.
Well done. I do that for a living, so I take my hat off to you for that.
And on the back, it's 95%. It's just solid copper ground plane. And underneath the RF section, there are no tracks at all. It's the only underside tracks are over on the digital side, all to try and keep the RFI down. What do we learn? Manufacturing is a nightmare. PayPal I absolutely hate for all manner of reasons. Not even Simon Cowell likes him, apparently, according to that. Royal Mail International, the say I was spending half my waking hours trying to deal with them. They're good. They've got a picture of Borat here going like that. UK manufacturing is good. I've gone over what happens to the 2100, there's only been 2 devices I haven't been able to fix. One of those is at Bletchley Park as a demonstration, not for live demonstration, but as an exhibit. And the other one my father takes to show his mates in the pub. Basically, if you spent 3 hours trying to fix one dongle, it's time to give up. And returns 0.5%. Funcube satellite funding now has some. We have basically there is a 5-figure sum in sterling. They're sitting for funding the Funcube satellite. So this I think is quite key here. If you have something that people are going to want, and you can do something, and you've got a project that you need to fund, this is the whole way. This is the way to do it. When you're talking about 5-figure sums for this, I just didn't think. I mean, I was thinking about in terms of 100. I wasn't thinking about thousands. And in fact, when I went to talk to the tuner chip manufacturer, who's more used to sort of selling these things in Taiwan, for guys who are going to say, I'm going to make 100,000 set-top boxes, and they've got me going to him and saying, oh, I might make 500, knowing full well I'm really thinking 100, and the guy's still talking to you 5 minutes later. I thought, actually, this is probably worthwhile pursuing. And they're fine, absolutely fine with it. And the SMA connectors are not now the most expensive part. As I say, they're 19p. I think we probably don't need to go through that. Perhaps I should say something about what's not good. I mentioned it's not good for hacking, but that wasn't what it was designed for. VHF selectivity is not great. I think we're pretty much, the design requirements will pretty much tick the boxes. In the future, okay, we're looking at, we need, as part of the educational outreach, we're going to need an antenna, and what we're thinking about doing is, it's going to be a very simple antenna, maybe a dipole, maybe a halo, something like that, but something that's simple, cheap to manufacture, but we're probably going to have to integrate some kind of filter in there as well. And David Bowman here, G0MRF, is working with me on that. We already have this is a design that I did, and I'm not an RF engineer, so this is why it's a bit of a mess. This is the VHF. This is a 6 megahertz bandwidth over on the 2 meter band. So you've got about 40 plus dB of attenuation. In the UK, we have real nasty pages around about here and around about here, and that was causing us some problems. So this is a SAW filter design, and the key, but the problem is SAW filters are not cheap, unless you're going to buy sort of hundreds of them. So we've got well, David's in charge of that piece, and if you want to talk to him about that in a moment, but that's that. Oh, the cast of people. I'm sure there are more. We've got Jim, the boss. We've got the front man over here, Graham. We've got Rob Stiles. Rob's not here, is he? No. The cheerleader. Yes. Good job he's not here. And we've got Trevor, who I've called the word on the street. G6LVB, that's Roger Ray. He's the guy who's been exceptionally helpful with regards to the certification piece. He's doing the FCC certification for me at the moment. And G4ULI, that's my father. He's the bookie, or the accountant. And my extended family, my nephews and nieces love me because they now have some holiday money. So they get roped into doing the envelope stuffing for me and whatnot, and everybody, of course, on the Funcube tech team, and everyone globally for the help, because there's been a lot of people who've been on the Funcube Yahoo group who've been exceptionally helpful and supportive, for whom I'm greatly indebted. And thank you for listening.